Okay, 4-7, completing the square to determine the root. So recall from yesterday's lesson, we had the quadratic equation y equals x squared plus 10x plus 12, which was not factorable when we tried to use factoring with the x to find the roots. However, based on the graph, we saw that there was roots that did exist. So how can we use completing the square, which we learned about, to find the roots of the equation? So the first step is to set the y equal to 0. And when I write this, for some reason, I always write the 0 on the right side. So I'm going to write it like this. So the equation becomes equal to 0. So the y I just moved over and put the 0 on the right side. It's just a standard way I always write it. So x squared plus 10x plus 12 equals 0. We're making this equal to 0 because we're looking for the zeros or the y-intercepts of the roots. They're all known as the same thing, and that always occurs when y is 0. So the equation is equal to 0. Step 2, we're going to move the constant term c to the other side. So we're going to minus the 12 from both sides. So now we have x squared plus 10x. We're going to leave some space and put minus 12. So we're going to leave spot for c. So move the constant term to the other side. Then it says use completing the square to find the new c value. So now we're going to use what we learned yesterday. And we're going to take the b divided by 2 and square it. So we're going to get 10 divided by 2 is 5. 5 squared is 25. So that completes the square. We're going to put that on the line right here. And I usually put blank lines. And then it says make sure you balance the equation. So if we're adding 25 to the left side of the equation, we have to add 25 to the other side, or else we're going to be making a non-true equation. So whatever you do to one side, you do to the other. So we're using completing the square on the left side and then balancing it by putting that same value on the right. Now we're going to write, so that's step 3. So then step 4, bringing this all the way down here, I can just put arrows coming down. So now we have x squared plus 10x plus 25 equals 13, because I just combined these two. All right, and then it says, step 4 says factor the left side. So this is perfect square. This is what we learned about yesterday. So once you do completing the square, remember, it's x plus b over 2, so 10 over 2 is 5 squared. And this is going to be equal to 13. And now to take this a step further, we're going to now use solving. And to solve this, remember we set the equation equal to 0, so we're going to move the 13 back over to the other side. This is going to be x plus 5 squared minus 13 equals 0. And you should notice now the difference of squares that we learned about with factoring a few weeks ago. So now we have our difference of squares. So we're going to factor by taking the square root. So we're going to have x plus 5 minus the square root of 13 equals 0. And x plus 5 plus the square root of 13 equals 0. Remember, the factors are going to be equal to 0. So we factored it. Each factor is equal to 0. So now we solve this. X equals, the 5 moves over and becomes negative, and the negative 13 becomes plus 13. And over here we have x equals negative 5 minus 13, square root of 13. And then, because we want to be able to check this on our calculator, this is the first answer. This is the answer as a simplified radical. So if you're ever asked to give it as a simplified radical, 13 does not simplify, so that's the answer. If you're asked to give the answer as a decimal, and I'm going to ask you to do both, okay, you're going to go to your calculator. You're going to do the square root of 13. Oops, not the square root of 3, the square root of 13, and which is 3.61 we're going to go with. And so we have, for this one, x equals negative 5 plus 3.61, which is negative 1.39. And then over here, we're going to have x equals negative 5 minus 3.61. So x would be negative 8.61. So then what we're going to do is graph this function. So we're going to graph the function. I use Desmos, I already put it in here. So there's our function. There's a graph that's formed by the function. Okay, and we can check our answers. The zeros should be the x-intercepts. And if you look here, negative 8.61 if we round it. And then negative 1.394, which negative 3.9 is where we rounded it. So you can check your answers by putting it in the graphing calculator and checking to make sure the values match. So that's how we solve using completing the square to find the roots. Okay, so let's look at another example. So example 2, consider the equation y equals x squared plus 8x plus 10. Use this method to determine the roots. Show your work. So we're going to do step 1. Says change the y to a 0. So we're going to write this as x squared plus 8x plus 10 equals 0. Okay, and then step 2 says to move the constant term. So x squared plus 8x. I always put plus blank because we're going to fill in the blank. We're moving the 10 to the other side, so it becomes negative 10. And then remember, whatever we do to one side, we do the other. So we're going to put the blank over here. So to move the 10 to the other side, we're going to fill in the blank in step 3, use completing the square. So completing the square, remember it's b, which is 8 over 2 squared. So that's going to be 8 over 2 is 4, squared is 16, and we're put that on both lines. Okay, so step 3 was to find that value. So now we have x squared plus 8x plus 16 equals 6. Step 4 says to find the left factor of the left. So if we factor this, we should get x plus half of b, which is 4, squared, equals 6. And then step 5, we're going to now factor this as difference of squares. So we have x plus 4 squared minus 6 equals 0. We factor as x plus 4 minus the square root of 6. And x plus 4 plus the square root of 6. And if we move the terms, we get x equals negative 4 plus root 6. And x equals negative 4 minus root 6. And to find the values for that, root 6 is equal to, so the square root of 6 equals 2.45. So we have negative 4 plus 2.45. Remember, the radical is one answer. That's the radical form. And then as a decimal, it's going to be x equals negative 1.55. And then again, this is a radical answer, the second answer. And if we put it as a decimal, we have x equals negative 4 minus 2.45. So x equals negative 6.45. And in this particular problem, they gave you the picture here. It says check your answers using the graph provided. So let's see if these answers look right. So negative 1.55, if you look on the graph as to where it crosses just between the negative 1 and the negative 2. And it says to label it, so that point would be negative 1.55, comma 0. It's the 0 of the graph. And the second answer is negative 6.45, so right around 6.5, which it is. So that point is negative 6.45, comma 0. Those are the zeros of the graph, which are also known as the solutions, which are also known as the roots or the x-intercepts. So lots of terms. So we checked our answers. We're all set. Okay, so let's look at a couple more examples, and then you can try a couple on your own. So the directions here are the same as going to be the 3 problems you're going to do on your own. Determine the roots of each quadratic equation by using completing the square. Give your answers as both a simplified radical and a decimal rounded to the nearest hundredth, so 2 decimal places. Check your answers by the graphing calculator. And you can use Desmos.com or your graphing calculator if you have one. So first step, we have x squared minus 6x plus 4 equals 0. Second step, x squared minus 6x plus blank equals, the 4 moves over and becomes negative 4 plus blank, sorry. Then we go to step 3, which is completing the square. So step 3, we're going to do negative 6 over 2 squared. So negative 3 squared is 9. So on step 3 of x squared minus 6x plus 9 equals 5. And then step 4, we're going to go to our factored form. So it's x, half of b would be minus 3 squared equals 5. Step 5, we're going to move the term. So x minus 3 squared minus 5 equals 0. And then we're going to factor that. So x minus 3 minus the square root of 5 equals 0. And x minus 3 plus the square root of 5 equals 0. So remember, those are our factors. So then we set those equal to 0. X equals a 3 becomes positive. The square root of 5 becomes positive. And over here, the 3 becomes positive. The square root of 5 becomes negative. And so this is our radical answer, so make sure you identify that as the radical answer. And now if we put the square root of 5 into a calculator, we get 2.24. So x equals 3 plus 2.24, which would be 5.24. And over here we have x equals 3 minus 2.24, so x would equal 0.76. So now we're going to put this in a calculator. So x minus 6, x plus 4. Here's the graph. If I go to my intercepts and click on them, we got the 0.76 and the 5.24. And I just realized I wrote this 5 instead of 4 here. 5.24. That would be the sum there. Okay, so you can see how you can check your answers with the graphing calculator once you finish solving them. So one more to look at together. So step 1, x squared plus x minus 10 equals 0. Step 2, x squared plus x plus blank equals a 10 becomes positive 10 plus blank. Okay, so we move that term to the other side. Step 3, now we got to take the term here is 1, so we're going to do 1 divided by 2 squared. 1/2 squared is 1/4, so we're going to put that on both lines. Okay, so x squared plus 1x plus 1/4 equals 10 is 40 over 4. So we can get a common denominator. So 40 over 4 plus 1 over 4 is 41 over 4. And then step 4, we're going to factor this. So remember, it's always x and then half of b. So plus 1/2, half of 1 is 1/2 squared equals 41 over 4. Step 5, x plus 1/2 squared minus 41 over 4 equals 0. So remember, it doesn't matter if you're working with fractions or whole numbers, you follow the same process. So now we're going to take the x plus 1/2 and minus the square root of 41. If we do the square root of 41 over 4, it's going to be the square root of 41 over 2, because the square root of 4 is 2, equals 0. And then x plus 1/2 plus the square root of 41 over 2 equals 0. And move our terms, the half moves the other side, minus 1/2 minus 41 over 2, which would be, if we combine this common denominator, we'd have -1 minus the square root of 41 all over 2. So that's the radical form. And then over here, same thing. We move the 1, we get -1 plus the square root of 41. Oh, sorry. This one should be, sorry, it was plus. It was minus, so this should be plus. And this one was positive, so it would become minus 41 all over 2. And so we have those terms. Now we find the value. The square root of 41 is 6.4. So we got -1 plus 6.4 over 2, which comes out to be 5.4 over 2. So x equals 2.7. And then if we do this one, x equals -1 minus 41 would be -1 minus 6.4 over 2, which comes out to be -3.7. So then we go to our Desmos. If we put the equation in, which I did already, there's the equation. If we go to our calculator, or our points, you see how we get -3.7 and +2.7. So again, you can check your answers. So when you get a fraction, make sure when you take the square root, you take the square root of this top and bottom. You're normally going to get the bottom's going to simplify to a whole number. It's going to match up, so you should be able to put these under one fraction. Okay, so combine them as under with the same denominator. That's your radical answer, and then put it in for decimals for your decimal answers. And then you can check your answers on the graphing calculator.